Jai Hind all. Myself Amita Asthana from Ajay Kumar Garg Engineering College, Ghaziabad. In this video lecture, we will be studying about the subject that is Digital System Design. That course subject code being KEC 302. And here we will discuss the very important topic from the third unit, that is SR Latch, which is the basic of designing any flip-flop or any latches. So let us discuss the SR latch. Here this is the block diagram for the SR latch. So what we are giving, that this we are giving two inputs S and R. The S is sometimes it is referred to reset and sometimes it is referred to reset. So set and reset are the two inputs which we are giving, and there are two outputs we are having. One is Q and another one is Q bar. That is, Q is just the inverse of the Q bar, or both are, as it has been shown in the diagram, that this is the logic symbol. If this is 0, that will be 1, and if it is 1, 0, then it will be 1, like that. So coming to the SR latch active high. So SR latch active high, the block diagram shows that there are two inputs. So we have given two inputs S and R in the logic diagram also, and there are two outputs, that is Q and Q bar. So here one important thing is, while making the SR latch, that this is a feedback kind of path which we are giving to each NOR gate. These are two NOR gates, G1 and G2, and we are giving two feedbacks. The first is going to, the output of G1 is going to G2, and the output of G2 is going to G1 NOR gate, and hence the SR latch is being designed. And here it is the logic diagram, that we need to remember this particular diagram, that this is active high. Okay, one more thing which is required to keep in mind, that the S, in front of S we are having the Q bar, and in front of R we are having the Q output. So this is being the logic diagram. Let us discuss how it functions. So as we know, whenever we need to change, there are four type of combinations we can use for this, that S and R. Two inputs, maybe both are 0, maybe 0, 1, 1, 0 or 1, 1. Let us see if these are the inputs, then what happens. One more thing is, since it's a memory kind of thing, and some feedback is also playing role for the incoming output. So here we need to consider all the cases where the Q is, maybe Q is initially it was 0, then Q bar initially it must be 1. So here the first case, let us discuss that initially, that the Q, the input, since it goes to the NOR gates as a feedback, so we need to consider what was the previous state of the output. Since this kind of arrangement, that's called kind of sequential logic. So SR latch consisting of a sequential logic design, in which memory and feedback plays an important role. So here the Q is equal to 0, that the initial input, and here that will be 1. So here initially it will go like this, and let us consider the first case, that is SR to be 0, 0. So here this is 0 and this is 0. So what would be the output now? So for 0 and 1, the output of the NOR gate would be 0. And here for 0 and 0, the output would be 1. So that means, let's say this was the case when q was 0. Let us discuss the case where when q is equal to 1 and it was 0, like this. Let us see what happens when the initial output was 1. There may be two possibilities, of course. So here 1 is going to this particular and this 0 is going to here. Now for 0 0 the output, this one will be 1, and for this 0 and 1 the output would be 0. So by observation we can see the for the first case, when s is equal to 0 and r is equal to 0, what is happening? The output, whatever the output was initially, it is coming as it is. That means the output remains same regardless of the initial condition. That whatever was the initial condition, the output will be the same when s is equal to 0 and r is equal to 0. So here when s is equal to 0 and r is equal to 0, the state of the flip-flop will be no change, and hence the output will remain as it is in that case, like 0 0, there would be no change. Now coming to the next case, that is 0 and 1. Okay, let us assume the s is equal to 0 and r is equal to 1. So the next case is s is equal to 0, s is equal to 0 and r is equal to 1, and let the output, initial output was 0. So let initial output was 0, that will obviously go here, and this 1 will go here. Okay, let us discuss the case for that. So here the s are like for 1 and 1. Okay, the output of the NOR gate would be of course 0. Okay, for 0 0 the output will be 1, right? For s is equal to 0 and r is equal to 1, right? This is the case we are discussing right now. And let us assume that it was initially 1 and now it is 0. So here let us see what the output comes. So here it will go like 1 and here it will go like 0. Now assume that the 0 and 1, for 0 and 1, the output will, of course, it will be 0. For 0 and 1, the output will be 0. No, but it is wrong that the q and q bar cannot be the same at all the times, because q is complement of q bar. So what is going to happen? So here this comes the concept that is these latches are level triggered. Yeah, they try to get the stable condition. So we need to send the this particular feedback once again. That means here it is again we are going to see for 0 and this output will go as 0. Now we will see the 0 0, the output will come out to be 1, and here for the 0 and 1, the output will come out to be 0. Okay, now it's okay. So here now this condition is okay now. So what we can say, when s is equal to 0 and r is equal to 1, the latch becomes takes the reset state. So why it is happening? Because at the level the SR latch is getting stabilized. So that's why this is happening. So if you are not getting q and q bar as the same, you need to try for one or two more feedbacks, and until and unless the level ends, this SR latch will get stabilized, right? So similarly we can do for the qn to be 1, we will again get the reset state, and for 1 and 0 you can self verify that this for 0 that it will go to the set state. Now for 1 and 1, both are 1. See, for both when the case, let us discuss the case when both are 1, right? So this is a kind of, you know, situation which is undesirable, and it is not clear also. So both are, 1. So this is to 1, this is 1, right? So if it was 0 earlier and this was 1, okay, right? So 1 and 0 will give you the output to be 0, and for 1 and 1 the output will be 0 again. Okay, so this is not the same. Again you will give 0, it will give you 0, and again whenever you will give this as 0, it will give you 0 again. So the 0 0 2 times it is coming, that means the flip-flop gets into the indeterminate state, and which is known as invalid state, and that is how the SR latch works. So this was the concept regarding the SR latch. Now we can have another arrangement for the SR latch as active low. So just remember that for SR to be 0 0 there was no change. For SR to be 0 and 1, that the latch comes into the reset state. For 1 0 the latch comes into the set state, and for 1 1 it goes into the indeterminate or indefined or invalid state. So here, keeping that in mind, we can have another arrangement for SR latch to be active low. For this, we will use NAND gate, and see, 2 NAND gates have been taken, and here Q and Q bar are the outputs, and S and R. What is the difference? Because just the table gets reversed. In SR 0 0, whatever was the Q, initial Q, that is 0 or 1 maybe, so it goes into the indeterminate state. For 1 1 it maintains the no change state. For 0 1 it maintains the set state. For 1 0 it maintains the reset state. That means the table gets reversed in this case. So we need to remember this particular case, that we are using 2 NAND gates, and S, in front of S we are writing the Q, and in front of R we are writing the Q bar. So here this is known as SR latch active low. The table initially gets reserved. Here we are taking 2 NOR gates active high. We are taking 2 NAND gates active low. In front of S we are writing Q bar, in front of R we are writing Q. In front of S we are writing Q, and in front of R we are writing Q bar, right? So now coming to the SR latch active low. So here this is one more arrangement which can be used for the same table, SR active low. That means for 0 0 indeterminate state, for 0 1 it is set state, for 1 0 it may remain in the reset state, and for 1 1 there would be no change. And similar is true for this SR latch active low. Now coming to the fourth arrangement of the SR latch, that is using the NAND gate. But what is the basic difference between these two arrangements? That we are using here two inverters, right? So we are using 2 inverters, and all the arrangement is same. The similar feedback has been given here, and S bar, instead of giving S and R directly, we are giving S bar and R bar to the latch, and hence we can get the initial table. And we need to remember this table for further references, and whatever the latches we are going to use, that will have this. But not to forget this particular table, that initially there is no S bar or R bar. If there is no S bar and R bar, it will act as SR latch active low, and if it is S bar and R bar, it will the table gets reversed, the initial table which we have studied and verified, and that is for 0 0 no change, for 0 1 reset, for 1 0 set, and 1 1 indeterminate state. Thank you.